Hi, everyone. My name is Greg Semler. I'm the founder and CEO of InPipe Energy. We're the host of this webinar. It really is amazing to see so much interest in this topic. We have people on the webinar from 9 countries and 10 states participating today. So I think we're all just really interested in looking at innovation that can ensure a reliable source of water in an environment of climate disruption. So we're really pleased to be launching this series. It's going to showcase experts and success stories of innovators in the water and energy industries. This is the first of 3, and so we really appreciate you taking the time today. Just a little background, I founded InPipe Energy about 6 years ago because I saw this really important opportunity to create a new way to accurately manage flow and pressure, and then be able to monetize that wasted pressure into renewable energy. I thought this would give water agencies a new way to reinvest into existing water infrastructure so that we could make water and energy more available and affordable for cities all over the world. So you'll hear more about that today, but our main focus is on hearing from innovative, experienced leaders from the water industry. We'll have time for Q&A, so let the speakers and panelists talk first, and then we can engage in some great discussion. So I'm going to begin by introducing our opening speaker, Mary Ann Dickinson, truly an icon and water industry treasure. She has over 50 years of experience working for water utilities such as the Metropolitan Water District in Southern California, the Regional Water Authority in Connecticut, and the EPA. She was the founder, president, and CEO of the Alliance for Water Efficiency, America's leading steward of sustainable water use, until retiring last year. She's currently the co-chair of the Water and Planning Network for the American Planning Association, and she serves on InPipe Energy's board of directors. She's going to describe how climate change is being addressed and how it's affecting water levels, then offer data from pilot projects around water and energy savings and its connection to the need for non-revenue water loss control. While these look unconnected, they are not. This data proves that curbing leakage and managing pressure can save energy as well as be a carbon reduction winner. So I'm really thrilled to welcome Mary Ann.
Thank you, Greg, very much. And it's a pleasure to be here. I'm going to share my screen and hopefully this works. So as Greg mentioned, I'm going to give you a little bit of my perspective on how climate change, non-revenue water, and energy all connect to each other. And I first want to give you a disclaimer. I'm a generalist planner. I'm not a climate scientist. I spent 18 years in state government as an environmental regulator and then 20 years in the water utility world, where I was a very proud employee with the mantras of duty to serve and silent, dependable provider and highest quality, water quality for our customers. Those were the most prevalent themes for us in the water utility world, still are. But increasingly, we're getting bombarded with new crises and new issues: water affordability, climate change, the need for greater water resource stewardship and source water protection. These are now forefront issues for water utilities all around the world. And so reducing the carbon footprint now for water utilities is now a priority for a lot of them. And what I want to do is just start into the climate change discussion by showing you a very fun image. If you have not seen this video, don't choose extinction.com. This is something the UN put out just shortly before the COP26 meeting. It's a hysterically funny and very sobering video all at the same time. And it's a talking dinosaur. You got to watch it. But it was one way to get everyone's attention, certainly among the general public as well. So I encourage you to take a look at it. Now, let's just launch into just a few frightening facts that I think relate to the whole issue of climate change and the water utility world. Based on the current rates that we're experiencing, global temperatures could rise by up to 4.4 degrees Celsius by the end of the century. While it doesn't sound like a lot, it actually will have a serious impact. The Intergovernmental Panel for Climate Change, the IPCC, has issued reports over the years, and they are urging that we limit the rise to only 1.5 degrees. We're now at 1.1 degrees at this time. So we really can't increase by much more. At 3 degrees, increase, 1 in 100-year events will happen every 2 to 3 years. So the massive floods we're experiencing are going to be much more prevalent. The severe droughts would be much more prevalent. And worse, 2/3 of humanity will experience drier conditions as the planet warms, because most of the population happens to be in those areas that are fraught with drought. And so it's sobering, because the differences between a 2-degree increase and a 3-degree increase, those differences are far starker than those between the 1.5 degrees and 2 degrees. So if we don't do anything, we are headed for a much more different planet. So lots of people have been thinking about this. Bill Gates wrote a book that he published late last year. And, his basic message in the book was, we're at 51 billion tons of greenhouse gases that we emit to the atmosphere every year in the world. And we need to get to 0. And that's going to be a sobering assignment. And to meet that 0 emission goal, we'd have to cut our own greenhouse gas emissions in half. And so he makes some recommendations in the book. I think it's a great read, and I highly recommend it. We need to change how our cities are growing, do better infrastructure construction. We need to shore up our national defenses. Utilities can save money in that regard as well. And most importantly, we need to connect the dots with the water supply. We need to better manage and improve our drinking water supplies nationally and across the world. So as you all know, there was an international meeting called COP26 in Glasgow in November of 2021. And 23 countries made a formal pledge to stop direct public financing for coal, oil, and gas by 2022, by the end of 2022, and to shift their investment instead to renewable energy. These were very important commitments that were made. Banks, insurers, and investors also pledged to make green investing a priority for them, and to center climate change solutions in their work. So those were important commitments as well. 100 countries committed to end deforestation by 2030. And while that all sounds good, there was a sobering report issued by the IPCC on February 28th of this year that further documented that we need to do a better job of adapting to the climate change that's happening. That's just as important, perhaps even more so, than mitigation and prevention of those emissions. We need to better adapt to what we are now experiencing worldwide. So I live in California. California is probably ground zero now for a lot of the drought issues. We're in a 3rd year of deep drought. Now that's after we had a drought already between 2012 and 2016 that was the worst drought in 1,200 years. And now we're back in another drought that is looking to be worse. We've had no rain during the rainy months of January and February. As people probably know in the West, it rains in January and February and March, and it doesn't rain for the rest of the year. We've had 0 rain in January and February. So water deliveries are at 5% of people's water rights. State board just issued a notice to water right holders saying you might be reduced even further. Lake Oroville shut down its hydroelectric plant for the first time ever because of low flows in the reservoir, not being able to operate the plant. And we're facing a situation where scientists are telling us that the snowpack is decreasing so much that the Sierras may no longer really have snow by 2040. And if you're in the water business, you know that that's how California gets its water supply, is from the Sierra snowpack. So this is serious news. And it's true for all throughout the West and the Colorado River system. There's a mega drought in the West as well. The Department of Interior declared for the first time ever on August 16th, a shortage on the Colorado River. There are 500,000 acre feet needs to be saved every year if we're to keep the downward trend of Lake Mead from ending up in a dead pool. And as of August of last year, 99% of the United States west of the Rockies was found to be in drought. And that's as severe a measurement as any in historical record. We are experiencing conditions that are not just the normal drought cycles. They are now becoming a much more sobering situation. Here's the U.S. Drought Monitor, which is a wonderful tool that's made available by the University of Nebraska. And you can see the drought that's intensifying around the United States. The darker the color, the more exceptional and intensive the drought is. But there's even drought in states like New England and Michigan and Wisconsin. These are not states that have typically experienced these kinds of droughts before. So we're seeing some real changes in the way drought is appearing, and water utilities and water suppliers are needing to deal with it. And that's kind of the big issue. We need to make sure water and climate change are dealt with as a combined effect, because water's like the canary in the coal mine for climate change. The effects are going to be felt both in water shortages as well as in excessive flooding in areas that are going to be wetter. Areas will be dry and will be drier, but there will be areas that will be wetter and will continue to flood in a more serious way. So these are dots that have to be connected. So what does this all have to do with non-revenue water? And so the good news that we want to talk to you about is managing pressures in your system and reducing leakage saves water, but managing pressures and reducing leakage also saves energy. And that's what we want to talk about. Because when you save energy, you're saving greenhouse gas emissions, you're saving carbon, and you can count the carbon that you're saving. So here's again, and I'm sorry to be very California intensive, but I have access to a lot of data from them, so it makes a good story here. But the state of California took a look, the California Energy Commission took a look at how much of their water supply and treatment and delivery to customers was energy intensive. And so they figured out what the electricity use was that was associated with water in California, as well as the natural gas use. And the numbers were really pretty staggering. I mean, 32% of California's electric energy use natural gas use is related to the consumer use heating of hot water. 19% of California's electric power production was related to the pumping, treatment, and also consumer end use of water. Those are big numbers. So when you save water at the consumer end and you avoid it having to be treated and pumped to that consumer, as well as heated at the consumer, you're saving, a fair amount of energy. And so there's a center at the University of California at Davis, the Center for Water and Energy Efficiency, who's done fabulous work in taking a look at what kinds of savings are possible. And I'm going to walk you through this chart very quickly. On the far left-hand side, the colored bar chart shows the electric energy utility investment portfolio for energy efficiency. And what it shows you is what those energy utilities have saved in terms of gigawatt hours for the roughly $1 billion a year of investment that the California state government allows for energy efficiency portfolios. And the second bar in the middle shows you what the investor-owned electric utilities have saved in terms of water conservation, what that energy results in. But the bar on the far right is the electricity that's saved by the water utilities, who have basically through their water conservation programs, saved electricity and greenhouse gas emissions through programs that were not reimbursed through the energy efficiency portfolios, but were actually just funded by water utility ratepayers. And you can see they've saved more gigawatt hours than the energy utilities did. So while California may be an outlier in terms of the intensity of energy in its water supply, it certainly documents well that those savings can occur. Okay, so moving on to the next slide, and they're doing it cost effectively. The orange bar chart shows that the electric energy utilities are paying roughly 38 cents a kilowatt hour for those water conservation versus energy savings. And so that's what they're paying per kilowatt hour for the energy saved. But the water conservation programs were saving energy at only 10 cents a kilowatt hour. So these are really interesting results that show that the water utility world is actually a much bigger player in the energy world than anyone really expected. So NRW is one of those ways, and that stands for non-revenue water. That's one of those ways that energy can be saved in a water utility system. Because there's so much embedded energy in water because of the pumping and treatment and pressurization, you know, if you're a utility that leaks a large amount of treated water out of your distribution system, you're not only losing money for that treated water, but you're losing valuable energy. And so the California Public Utilities Commission decided to take a look at that and to try and quantify what that savings might be. So they launched a $10 million pilot study from 2007 to 2009. They took a look at 9 pilot programs that were jointly conducted between water and electric utilities to determine how much energy could be saved in what we call cold water conservation programs. So this is water that's saved that is not heated, you know, say a shower or clothes washer. It's instead water that's just delivered like to your toilet or to the house. It's just counting the energy that is in that delivery process. And so they wanted to determine what the potential for long-term energy savings would be if those water efficiency programs were adopted on a more widespread basis. And so what they found, much to everybody's surprise, was that the results showed that of the 9 pilot programs, the pilots with the highest energy savings were distribution system leak detection and pressure management and low-income, high-efficiency toilets. So the distribution system leak detection pilot was run by Southern California Edison in 3 demonstration communities, and the results showed that this pilot program appeared to offer the greatest energy savings potential at relatively low cost out of the other 9 pilot programs. So this was important information, and the data that that study provided is very valuable into this discussion, because what they determined was the recoverable leakage economically for the 3 demonstration communities ranged from 60 to 116 million gallons per year of water saved, but the total embedded energy saved in those systems from the repaired leaks was 178,000 roughly kilowatt hours. And the total potential energy that could be saved with proactive leak detection and pressure management in the 3 communities was as high as 583,000 kilowatt hours. So these are not small numbers. So what does this mean for you as a water utility? You need to compute what your embedded energy numbers are for your pumping and treatment types, as well as for each one of your water supply sources to see where there's variation. You know, groundwater that's pumped is going to be different than surface water that's delivered. If surface water is pumped up at large elevations, you know, that's going to have a high embedded energy value. But once you've figured out what all that is, and you know what your values are, efficiency programs can be designed to optimize your utility operations and to minimize the amount of energy that's needed for the highest energy using supply source. And so as a result, water savings and greenhouse gas emission reductions, these are all byproducts of better NRW management. And this leads me into a solution that's one way to capture this, and that's the NPRV that we're going to talk to you about in the rest of this webinar. And it's a terrific turnkey real-time sensor-based modular system, and it'll integrate well with existing utility pressure management programs. And so at this point, I'm just going to finish by showing you a last slide that I'm sure Greg will want to talk about, which is the dashboard that shows in the NPRV what energy is being saved, as well as how the pressure is being managed. But it's time for me to stop and to turn it over to the good stuff of this webinar, which is the panel of utility managers who have already had experience with this product. So Greg, I will turn it over to you.
Thanks, Marianne. That was really scary. You know, it seems like the water industry has some major headwinds that it needs to address with these unpredictable climate disruption. I was really the amount of drought that's going on in the United States is really shocking, and I'm sure it represents the rest of the world as well. So clearly we need to think differently to tackle these systemic changes. So thanks very much. That was very insightful. So I want to get the panelists introduced and hear what they have to say about addressing these harsh realities. So I'm going to introduce the panelists. I'm delighted to introduce all of you to 2 water industry visionaries from the Pacific Northwest. We've chosen these 2 because they took a chance on installing the NPRV in Pipe Energy's pressure recovery valve. We think it's important to have them share their results to inform other utility executives interested in innovation addressing climate disruption. So I'm going to introduce them, and then I'm going to ask them a few questions, and we'll bring back Marianne and open the floor for Q&A. So first, Eric Hillema. He's the engineering manager of the Hillsboro, Oregon Water Department. Hillsboro manages the production, transmission, and distribution of potable water to a population of over 400,000 people. Eric has been managing the design and construction of water, wastewater, stormwater, energy, and architectural projects for over 25 years. And we're really excited and delighted that he's here today. George Sidhu is our second panelist. He's the general manager of Skagit Public Utilities District in Mount Vernon, Washington. Skagit PUD operates the largest water system in the county, providing 9 million gallons of piped water to about 65,000 people every day. The PUD maintains over 600 miles of pipelines and has over 31 million gallons of storage volume. George has nearly 30 years of civil engineering and project management experience in both the public and private sectors. So I'm really excited that they're here today. So gentlemen, we just heard from Marianne. Let's start with the big picture, climate disruption. And I know you're not in California, but other changes are taking place. And Eric, for you, why don't we start with you? How does this translate to decisions you're making in the city of Hillsboro?
Well, first off, calling me a visionary, I don't know, I deserve all of that. But I mean, it is a big deal. And of course, if you're from the Pacific Northwest, you know that a lot of people don't even think about climate change because it rains all the time, right? But we're still in drought. In any event, it really comes down to having a broad portfolio of thought on the issue, because there's direct impacts and indirect impacts, and it's all about the resiliency of the utility. So direct impacts with climate change for us were surface water supply. So we own a reservoir in partnership with several other entities, and then we lease storage in another reservoir. If those reservoirs don't fill up, then we have a supply issue. And similarly with climate change, you get things like additional forest fires. And because of those surface supplies, you can get combustion byproducts running into your water supply. You can have erosion from denuded areas in the watershed. So there's a whole host of other impacts that can directly impact your ability to supply water. But you also have to think about things like carbon offsets and doing those things you can to long-term address climate change and increase the resiliency of the utility. And a lot of times when you're talking about subtle long-term goals, it tends to be noise to a lot of people, but you just have to keep driving those things home.
Thank you. So George, how do you think about climate change and this whole unpredictable environment that we're in, and we're heading toward worse?
Yeah, like Eric said, in the Pacific Northwest, you don't really think of climate change because it is really wet. And so the picture behind me is a photo of our raw water reservoir. And I feel guilty because Marianne's photo showed reservoirs in California that were really low, but we are fortunate that we have a raw water reservoir, but it is fed by surface water. We fill that reservoir with snowmelt and precipitation, and both of which are heavily impacted by climate change. You know, it's a different scale, but we've had 3 years of drought in the last 7 years in our region. And that's impacted how we operate this reservoir. So direct impacts, number one, is managing a reservoir this size. It's complex. You need to manage your surface water inflows. We have a secondary source, but being able to manage your inflows with your demands, you know, that's a challenge, and there's costs related to that challenge. The second direct impact for us is that if we don't get that surface water runoff into this reservoir, our secondary source is a large pumping station that pumps water from the Skagit River. It's a pump station that has 5 900 horsepower pumps that pump 5,000 gallons a minute. So we don't like to pump. It costs a lot of money. It's like Mary Ann said in her presentation, that's a lot of embedded energy costs into our water delivery if we turn that pump station on. So that is also an impact of climate change. We've had to run that pump station a lot more in the last 7 years. In terms of statistics, typically we spend about $260,000 a year pumping as a secondary source. But in our drought years recently, we've had to pay 30% more in energy costs just to manage our reservoir. So that's a very real impact to us and to our customers.
Thanks, George. I'm really kind of curious, George, do you use the word climate change or resilience, disruption? Like when you're talking to your commission, your board, your management team, do you talk about that?
The word that we use more often now is resilience. I think with the recent EPA risk and resiliency assessment, that was a big project for us and it was important to us. And so now that is how we are using that report to frame a lot of our capital projects and how we look at operational changes within our system as well. Resilience reflects your level of service. And so that's really important to us.
How about you, Eric? Obviously you're in a city that's very industrial, but that has a long history of sustainability and sort of a commitment to reducing your carbon footprint. So how does that play out in like your management team meetings? Do you talk about climate change? Are you looking for projects that can address resiliency and so forth?
Well, yeah, we're always looking for opportunities to increase the resiliency of our water supply. We do talk about climate change internally, specific to direct impacts, as I mentioned in the first question, such as just filling the reservoirs or forest fires. In terms of talking with decision makers, it's almost always about resiliency. So yeah, we have a long history. Our city council has a long history of supporting sustainability projects, and resiliency marries perfectly well with sustainability because ultimately you have the same ultimate result.
Mm-hmm. So George, you mentioned running a water agency is complex. I know it's a really busy job, and you're dealing with lots of priorities: aging infrastructure, rising energy costs, water loss, water quality, all very clear priorities. How'd you decide to take on an innovative new project like the in-pipe one when you're so busy already?
To us, as I mentioned just a second ago, it boils down to level of service. There are a lot of priorities that all utilities have to manage. And whether it's managing pressure within your system, aging infrastructure, all of those kinds of things can lead to non-revenue water and increased operational costs, disruptions. I think when you talk about innovative ways of improving your system, resiliency has to be a part of that discussion as well. You have to make resiliency a priority to keep that level of service high. As water managers, it's on us. It's important to us to deliver that high level of service to our customers. And so, resilience for us, obviously, the obvious resilience factor is seismic resilience. There's a lot of utilities that have to deal with tanks and pump stations, keep them online during emergencies. But now energy resilience is becoming an issue. And it is for us. We're a smaller utility in comparison, but it is a factor for us. We have to look at our costs, and the more resiliency we can add into our system, again, helps to reduce operational costs, help to deliver a higher level of service to our customers.
Yeah. So we ended up working with each of you. Eric, you were the first to install NPIPE's NPRV within your system. In case listeners aren't aware of it, the NPRV is a first of its kind recovery valve. It sits alongside an existing control valve and converts the flow of water into renewable energy. It also provides real-time digital data to track water loss and energy recovery. So how did you decide, Eric, to take on a project like this?
Well, unfortunately, I was not working for the city of Hillsborough when they undertook the project, but I mean, one, you guys made it easy. And since the Hillsborough City Council has a history of supporting sustainability projects, doing things like this is a no-brainer for our city council. If the bottom line and end result meet your financial as well as your social goals, it's a pretty easy decision.
So George, I know you and your team really wanted to be the first, and you are the first in Washington. So how did you decide to prioritize the NPRV? What was it about it that made sense for Skagit PUD?
Yeah, first and foremost, it's our vision to be an outstanding regional leader and innovative utility provider. And we try to live that vision on all of our projects. And so an interesting part of our story is that we constructed the Division Street Reservoir and Pump Station where the NPRV is located. We constructed that before we even knew the NPRV existed. So we have an engineering manager, Mark Hanslick, who's a very innovative thinker himself. And he directed our consultant to design the pumping for a future micro hydro generating unit. And that pump station was in operation for 3 years without it. But when the NPRV became, was made aware to us, it was, like Eric said, it was a no-brainer. It checked a lot of boxes for us. It worked to reduce our operational costs because we have pumping costs on that site. It was an innovative product, which we really liked. It matched up with our vision. It was a sustainable energy source for us without having to pay for power off the grid. And then it gets back to resiliency. It provided resiliency to our system to make sure that our pumps were able to operate even during power outages.
So George, how do you actually monetize the energy at the product site?
At Division Street Reservoir, it's one of our largest reservoirs, 6.4 million gallons, and it's a central site in our system that we then use to pump water to somehow higher elevations. So we've got a lot of energy costs that we just have every year, and having the NPRV at this site allows us to save about $12,000 a year in energy costs. It's not huge, it's not going to offset all of our energy costs at that site, but it does have a reasonable payback period for us. And again, it checked the other boxes as well. So the operating cost reduction started us down this path, but then we realized that it does offer a lot of other advantages as well.
And how about you, Eric? I think the site in Hillsborough will generate over $1 million in energy savings for you over the project life. How can you describe for the people that are listening how you actually monetize that energy?
Yeah, absolutely. But let me also first just say that for the project managers out there, you're all aware that a successful project means that you don't get any complaints from your operators. And so the in-pipe project for us has been extremely successful. It's almost we don't even really talk about it because our operators don't have to think about it. With respect to monetizing it, here in the Portland region, the main energy producer has rules about how you can set up net metering, and you should make sure you pay attention to those in your planning process. In our case, it's sited next to a stadium, a minor league baseball stadium that the city owns and operates, and we feed power back. We have a constant flow to the in-pipe unit. I think we have an uptime of about 98%, and the only time it's been down is when we needed to take it down for other activities. And it feeds into that meter, and then we do an internal audit through our finance department because I think we have 220 different power invoices a month, and then they credit the water department back that energy cost.
Okay, great. So Eric, the NPRV in Hillsborough has been operational for well over 18 months. Has it met your expectations?
Absolutely. As I led into the conversation, The operators were extremely cynical about it, as you remember, as they always are with anything new and anything that's going to change their daily lives. And they got their input, they got the things they wanted, and like I said, we rarely talk about it because it's just sitting there running. They don't have to do much maintenance, and from my perspective, because they're my customer, it's a successful project.
That's great. Have there been any unexpected outcomes?
Not really.
No negative ones.
I always like to go. We post the power generation data on our public facing website, and I like to go look at that once a month just to see how we're doing, and it's performing as expected.
That's great to hear. So how about you, George? How is it working within your team and for your system?
Yeah, I'll echo what Eric was saying. The operators, I think, question new and innovative products if they haven't been tested before, but our operators have been very happy as well. The NPRV has performed as expected, and our unit has been in operation for just about a year. And initially, the operators even took it upon themselves to try and optimize how much energy they could get. There was a model of how much energy recovery we were going to get, and they changed some of our pumping runs and tried to tweak it a little bit. And I think the unit is even outperforming the modeling that we did initially. So there is a real investment from our operators in this product, and it's performed well. And it's a neat thing to talk about because it is unique for this community, and I think people are proud of it.
Yeah, that's great. I wanted to ask you about that. Like, what has been the community response to having an innovation like this in Mount Vernon?
It's been good on a couple of different fronts. When I talk to local elected officials and other people, they're proud of the fact that a local water utility is the first to do something and to do an innovative project like this. So they're interested, number one. And then next, the conversation shifts to, well, where else can we do this? And so we've had inquiries from local industry, from a local school district. Even the local city of Mount Vernon has asked us if there's other applications for us. So they recognize that there's an untapped energy source within the water system. And now, Sam Shipp is one of our project managers, and I know that they're in conversations with a lot of people about where else this can be applied. So there's a lot of community interest, and a lot of the press that we've been getting through this as well has been nice. People recognize us as that innovative utility provider, so people are proud of that.
Yeah, you guys have really been showcased and featured as true leaders in this challenge of addressing climate change. So how about you, Eric? Have you had any community response to what you're having the project in Hillsborough?
We certainly get inquiries that people generally get referred to our website information, but certainly, as with most utilities, part of your resilience is having credibility with your ratepayers. And so we do a lot of advertisement of our accomplishments, of projects and other things. And we've certainly posted a lot about it. Our decision makers are really happy. And just like George, the next question is, where else can we do it? In fact, I'm due to provide a white paper to one of our assistant city managers about where else we can add in pipe. So it's positive when people ask about it. Most people really appreciate it, but of course, like most utilities, it doesn't necessarily reside in most people's conscious brain.
Yeah, well, I'm glad that you're thinking about doing additional projects, because we really believe that having NPRV system wide so that we can optimize energy and water within the system makes a lot of sense. So I want to thank you for your insightful answers. We've got about 10 or 15 minutes left for questions. I wanted to invite Marianne back and open up the dialogue. So Amy's going to join us as well and help us through any questions that you might have. So if you have questions, put them in the chat box, and you can ask questions to any of our participants today.
So I have one from Pierce. It is, let's see, with oil prices on the rise over the last year and more severely recently, I imagine energy savings have increased, and that's verbatim. Anybody want to take on the energy costs?
I would assume that that statement is correct, Pierce. The challenge is that the utility companies don't do a great job of documenting your net electricity usage along with cost. I think it's in their best interest to kind of keep some things in their back pocket so they're not overpaying for net energy provision. So I don't have an actual answer for you, because our internal audit is just about crediting energy production back to the utility as opposed to how much savings we're achieving.
Yeah,
And I would add to that, I would think that with the prices going up for fossil fuels, I mean, oil is now very expensive. So it depends on how your electricity is generated in your area. If it's generated from fossil fuel sources versus renewables. California right now has got a lot of renewable energy supply, but not everybody does. So if you're reliant on fossil fuels, your energy costs are going to go up at the utility. So the desire to save that energy is going to only intensify.
I have a funny
sorry,
question.
George.
They want to know if we paid you.
Oh.
The answer is no. Here's another one. If you could, you talked about it, so maybe that question's been answered, but if you could, would you install more? Would you recommend that people would install more than one at a time? Or is that pretty, would that have been more efficient, or what would you recommend?
For us, we did a study about 11 years ago to look at micro-generating potential within our system. And we had some sites. Nothing came of that until recently with the NPRV, but we still are looking at those sites again. Our challenge is that we're not the electric provider in our community. And so the net metering issue and where we can install them is a whole separate discussion with our local power provider. And so we need to get that straightened away, because we do have a desire to put in some more, because this can be beneficial to not just us, but other local partners that we have. So we need to get over that hurdle of the local power provider. But if and when we do that, I'll say when, not if, I think we have a lot of potential locally.
I would just add that initially, until your operations staff are comfortable, probably one is a good start. But I can say with confidence now that if I proposed a laundry list of installations, it would just be another project for them. And so if we had the locations and the time and money to make 2 or 3 of them happen at a time, it would not be that big of a deal. It's pretty simple stuff, actually.
And Greg, you might want to talk about the analysis that you offer to utilities as to in-pipe suitability.
Thank you. That was a question. How do you get started?
Yeah, you get started by the amount of energy that we can produce is a function of the hydraulics. So it's flow and pressure at a given time. And so what we have to do is we have to collect data at a particular location on what the flow and pressure is. And if you can provide us that data, then we can give you what we call a hydraulic analysis and potential energy assessment. And we offer that for free. We do it system-wide. So as many site locations as you're curious about or thinking about, we have the tools and the staff who's really motivated to look at this data and help see if the NPRV can be a solution for you.
And the economic assessment as well?
And you know, once we identify the potential energy, if you can then provide us energy bills for that location, that particular meter, we can start to estimate what the economic impact will be. And we have 10 steps that we call is our process for doing a successful project. And so step 1 is this hydraulic and potential energy assessment. Step 2 is an economic assessment. Step 3 is a site visit, so that we can really see what the economics are and the opportunity for the water utility to deploy the system. And we do all that for free. And we do most of the heavy lifting so that your staff, who we know is really, really busy and has other priorities, but may still really be interested in building a more resilient system. We do all of that for water utilities, and for the most part, we do it for free.
Hey, Greg, one thing that you failed to mention that I think really should open people's eyes is, at least in Oregon, and I think most states have similar programs, but because of the subsidies provided by multiple agencies for us on our in-pipe project, the cost to the city of Hillsborough was about 25 to 30% of the total project cost. So the return period and financial feasibility were just very easy.
Yeah, I mean, that's a good point, Eric. I mean, I think we all know that billions and billions and billions and billions, almost trillions of dollars is flowing into energy and water infrastructure. And our team is really keen on getting that capital from either water, but especially from energy, to bring to the water industry. And NPRV projects like we're talking about today are generally very applicable to that opportunity. So that we can bring in money that can help really build out your infrastructure and make it more resilient. And we do all that heavy lifting. We do the grant writing for free. We work really closely with water utilities who are motivated and interested in this area.
And I'll just add some specifics to that comment, because people are probably wondering. The installation of our unit cost of the project estimate was about $400,000. And so our investment was 25% of that, $100,000. You know, Greg was really good about getting grants from energy programs. Even the local power provider here provided a grant. So having that additional funding really allowed our project to go forward. And so that was a really great opportunity for us.
I have another question. So I've got 2 questions. Whoops. Does the NPRV require intensive O&M?
No. That's the beauty. I mean, it's a water turbine. There's just some semi-frequent checks and maintenance that you have to do, but there's not a whole lot you can do to it. There's an associated PRV, but since those are all connected to our SCADA system, they're monitored, and we haven't had to do any maintenance on it in 18 months.
I think for us, most of the time our operators have spent on it, we're trying to tweak it and optimize the energy recovery. So.
This is a good one, Neil. Thank you. What were the initial stakeholder concerns? Parentheses, my stakeholders have concerns over the equipment causing bursts. And how large or small can the units be in terms of kilowatt size?
Maybe I'll go first. Stakeholder concerns for us were, I probably had the biggest concern out of the stakeholders internally for our organization, and that was cost. I wanted this was a good project. I wanted it to go forward, but I also wanted a reasonable payback period because you have to, if I'm going to talk about this with our customers and our other local partners, it's got to make sense from a number of different perspectives. And so again, when Greg was able to secure a lot of funding for us, brought our investment down, that satisfied my concerns, and there weren't really any other stakeholder concerns. It's within a existing pump station for us, so it didn't really change what was going on.
As far as bursts, I mean, the ideal installation is where you're dropping pressure anyway. So either you have a PRV or you're discharging into, some type of gravity setting, and it's not going to change the pressure profile of the flow of water. It's going to be exactly the same.
Stakeholder concerns, Marianne, just elaborate a little bit. So stakeholders are, if you're in the middle, let's say you've got board members and your general manager, and then the engineers who work for you, you get different kinds of concerns, right? One is the mechanics, and the other is how much is it going to cost? Have you felt that you had enough information and the success rate was sufficient to address all of those concerns at all levels?
So in addition to working for water utilities at the retail and wholesale level, I also was a sitting board member of a water utility. And that was the most useful and instructive role to be in, because I saw how those decisions get made at the board level. And they often don't get made for reasons that you would expect. I tried to sell my board on installing more energy efficient pumps. And they said, well, that's not going to appeal to our customers. Ribbon cuttings are much more sexy and interesting. And cost is always an issue at the board, always an issue. So that's why I think this product, I think, deals with a lot of those issues. Stakeholders who come to board meetings are always concerned about how this is going to impact their water rate. And water rates have been steadily going up over the past several decades. They stayed relatively flat for a long time because growth helps subsidize the cost of the system. But many communities are not growing, they're actually shrinking in some places. And so costs for water deliveries are going up. And that's the big concern that we see in most stakeholders. So I would agree with what's already been said about, cost is always the most primary consideration for consumers.
So someone just said, are you saying that you help find funding?
Yes, we start that at the very beginning. We are very passionate and capable of finding funding to do these projects and to do most of the heavy lifting that's required for these projects. And it's been really gratifying that even the electric utilities are very excited about what InPipe is doing. They're kind of worn out on solar projects. And so again, they want to be innovative too. And so we've had a really good response from water utilities interested in participating in these projects as well. So there is a lot of capital. There's a lot of different ways that these projects, the economics for these projects can happen. There's incentives as well as grants, and we do all that work for you.
And Greg, you should also, I think what people need to know is these, as with most energy projects, it really does require a partnership, not just of the provider like InPipe and the owner, but great organizations, in Hillsborough's case, the Energy Trust of Oregon, which have subject matter experts, financial experts, and they play a big part in helping facilitate these kinds of projects.
Yeah, I mean, InPipe is truly at the nexus of energy and water. So it can be complicated and it can be expensive. And we just try to demystify all of that. We try to keep it simple. We try to bring in the right partners and make this as easy as it can be for the water utilities.
One of the reasons I've been really motivated on this issue is that I don't think the water utilities get nearly the investment that the energy utilities do for the same amount of savings. And that's a policy that has to change, and that I have been dedicating a number of years of my life to doing. Testified before Congress, begging them to recognize the role that water utilities play in this energy water connection. But that will increase, I think, over time as more and more water utilities are recognized for their greenhouse gas emission reductions. Right now, the energy utilities get that credit for the carbon reduction. The water utility who funds it doesn't. And those are things that I think are going to change on the national stage and the state stages everywhere.
Well, I think the challenge is really water utilities are so busy, keeping the system going. And they don't, and because they don't, and the system is underground and they don't really embrace innovation, they just want the system to work. Whereas in the energy industry, there's all kinds of innovation happening. They're showcasing it, they're
'Cause there's
publicizing
money.
it, they're talking about it.
Yeah.
That's what we need to do.
Yeah.
And that's why it's so great that Eric and George have been willing to step out and say, you know, this is important. We want to be leaders. We need to change the way we were thinking in the water industry. And here's an example. And that takes real leadership. And we just need more of that from water agencies. And I think the industry will attract more capital. Plus, it's super cool. I mean, water infrastructure is really, really interesting. People just don't know enough about it. But when you talk about it, people go, wow, you know, let's protect the most important resource on the planet.
Don't have any more questions.
All right, so thank you. I'd like to leave you with two messages. First, if you're interested in energy recovery and water loss control, it's helpful to know that our team has the expertise to do a lot of the heavy lifting, so you and your staffs don't have to. As I mentioned, we do a free system-wide hydraulic and economic assessment to address feasibility. And I want to underscore the idea that installing one NPRV can make a real difference, but installing them with a system-wide approach can have enormous impact on optimizing energy and water throughout your system. You're going to get a discussion guide that has our 10 steps to a successful project and our contact information. We'll also send you the recording of this event so you can review it or pass it along to your colleagues. So I want to thank you. I want to thank the participants. Thank you, Amy, as well. Many thanks to all of you who participated today. I look forward to seeing you at the future webinars. And if you're interested in learning more about the potential for the M-Pipe solution at your facilities, call me or email me. I welcome the chance to connect. Thanks a lot. Have a great day.
All right, bye everybody. Thank you.
Bye.